will allocate unsigned 8 bits of memory. Unsigned, see, I'm adding something called unsigned 8 bits. Unsigned 8 bits means it will have only positive value. Byte allocates 8 bits of memory. Byte is what? Signed 8 bits. Signed. That's why we have minus 128 to plus 127. Because that is a signed. Signed will have both negative and positive. When you say unsigned, it will have only positive. So unsigned 8 bits. Unsigned, and here it will take unsigned 16 bits. Okay. What is the range of unsigned 8 bits? If it is unsigned 8 bits, what would be the range? What would be the range? Signed 8 bits range is what? Just as said, signed 8 bits means minus 128 to plus 127. Is that not? Is it for signed, right? Signed 8 bits is minus 122 plus 127. Plus unsigned 8 bits, then what is the range? What is the minimum and what is the maximum? Hmm? 0 to 127, 255. 0 to, say, the moment is unsigned, the minimum will be 0. Minimum will be the smallest value comes to 0. Max will be what, how many negative numbers are there? How many are there? Minus 128 to minus 1. How many are there? 128, right? And then 0 to 127. So, when I'm saying unsigned, all the negative numbers, how many negative numbers are there? It will be extended towards the positive number. So 127 plus another 128 number can be accommodated. So 127 plus 128 will be 255. So it will be 0 to 0 to. Getting now? Similar here, signed. There is a signed 16 bits. Signed 16 bits is what? Minus 876882. Like your short, right? Right? Short is unsigned, signed. Short is signed. Okay, so it will be this. Right. But unsigned is what happen? There is unsigned, it will be 0 to 655. Okay, now see how exactly represented. In case of signed 8 bits, see both the cases 8 bits. Both the cases memory will be allocated 8 bits. But here the range is minus 120 plus 127. Why? Because 7 bits are used for value. 1 bit for signed bit. 1 bit for signed bit. 1 bit reserved for signed. Only 7 bits will accommodate your value. But here no signed bit because the number is unsigned. So this is your 0. All the 8 bits are 0, it is 0. And all the 8 bits are 1, it is your 55. Yesterday, last class discussed, 7 ones are what? 127. 7 ones are 127. This is 2 to the power 7. 2 to the power 7. 2 to the power 7 is 128. 128 plus after this we calculated last session 127. 128 plus 127 is 200. Now you calculate like 1, 2, 4, 8, 16, 32, 64 and 120. If you add all the numbers, it will be 255. Okay, so if you take 255 divided by 2 now, get the binary, you will get 8 ones, 8 10. So minimum is what? 0, maximum is 255. Right or not? You know same thing. This is what your 0. Odd ones, all 16 bits are 1. That is your 6 by 5. 6 by 5. Right? Is it here? Now say the formula if you get 0 to 2 to the power 8 minus 1 actually. 2 to the power number of bits minus 1. 2 to the power 8 is 256. 256 minus 1, 255, 0 to 255. 0 to 2 to the power 16, which is 6 by 36 minus 1. Yes. Okay. Now come to the point that this variable is what type of? What type? Character. When the variable is character type, we should discuss which character will be stored in the variable, right? Which is the character we can store into the variable ch. But why we are talking about the numbers we can store? Why we are discussing that minimum is 0, maximum is 255. It's not a number type, no, it is a character type. Right? If it is a byte, a short, int long, then we can discuss what is the minimum value, what is the max value we can store, right? But it is not a character type, right? That is not integer type. This is a variable of type of char means it can hold one character. Then we should discuss what are the characters we can store into ch, right? But rather than discussing characters, we are discussing the numbers. What are the numbers we can store? 0 to 255 number. Why 0 to 255? Why we are talking about the terms of numbers? This many number of characters. As you know, every C, for example, you want to tell me is C is equal to A. Okay. Character CH. CH is a variable of type character. It can hold a character. What is a character? Any one character enclosed in single quote is a character. Any one character is a character. So C is equal to this is also valid. 9 is also character now. 9 is a number, but when you're writing 9 in single quote, it becomes a character. Character C is equal to suppose last. This is also a character. Okay, like I will take it star. Any character take character C is equal to bracket. It is all word now. Characters. So any character you store in single character is constant. Now, how it is represented in computer memory? Every character has a value. Every character has a value. Okay. When you say char C is equal to A has got a value. That is called ASCII value. That's called the ASCII value. The ASCII value of A is 65. So 65 will be converted to binary, and that binary value will be stored into the memory. If someone asks, how this character will be stored in the memory, then you have to say it's ASCII value. It's a ASCII value. ASCII value of A is 65. 65 will be converted to what? Binary. converted to binary, then that will be stored in the memory. So if you look at like this, character and ASCII value. ASCII value starts when the character called the null character. Null character, its ASCII value is 0. Null character ASCII value is 0. Like 0 in a single code, its ASCII value is 48. 9, its ASCII value is 57. Capital A, ASCII value is 65. Capital Z, ASCII value is 90. Small a is 90. Small z, 122. Like this, we have 200. Then how many characters are there? They started with what? 0, ends with the 255. So 0 to 255 are the ASCII values. And these are values are assigned to a particular character. Every character like plus, minus, multiplication, division, whatever you see on the keyboard. Even including enter key also have ASCII value. Enter key, backspace, single quote, double quote, dollar. No, everything you see on this keyboard will have a value. And the value starts with the word 0, ends with the. So any character you choose from the character, its value is between what? 0 to 255. 0 to. So whatever character you are showing, CS equal to A, then convert A to binary and represent it. So maximum value is what now? 255. Minimum is 0. How much of memory required? 8 bits is enough. You take 8 bits of memory, minimum we can store 0, maximum we can store 255. So if you take any character from this character list, we can accommodate into the character variable in C if it allocates 8 bits of memory. Understood why it is 8 bits? No. You take random series of now I have taken 8. Ask you if you what now? 65. 65 can be stored here or not? Convert 65. Maximum we can store 255. Minimum 0. If you take any character, the final last value will be 255. First will be 0. There is no character beyond this now. Then there is no much memory required. Only 8 bits is enough. That's why we take 8 bits of memory in the character C++. Okay. Now it said, so if it is 8 bits in C++ and C to store any character, then why Java is 16 bits? Same characters are there in Java also. Then why it takes 16 bits? What is the need of 16 bits? We can same 8 bits we can accommodate, right? Yes or no? Definitely there will be a question. These are the character set. 256 characters are there. Any character you take, its value will be 0 to 255. Then why we required 16 bits of memory? And here I am saying what? 0 to 65. And then how many characters are there? 65,536 different characters can be stored into character variable in Java. When C++, 256 different characters can be stored. Whatever the remaining characters can now. Special character orders. How many? All special characters include here only. How many special? 65,536. Think about it. How many special characters are there? We don't have those many special characters, right? All special characters, what do you see now? Exclamation, @, dollar, hash, less than, greater than, plus, minus, left bracket, right bracket, square bracket, everything is included. Including tab, backspace, enter key also. So the thing is that here why how English has 26 alphabet now. ASCII it supports only English alphabet. Only English alphabet. It does not hold any other characters, any other language alphabets. In C, C++, if you declare a variable of type char, It can store any value which is having an ASCII value between 0 to 50. It means only English alphabet we can store. Any other language alphabet, if you want to keep it, it's not possible. It does not support the universal code. Okay, it supports only ASCII code. ASCII is only for the English alphabet. But Java supports only universal code, Unicode. Like how ASCII is there now, we have a Unicode. Unicode is in the range of 0 to 65535. Unicode is what? Think about how many languages are there in the world. And each language has got its alphabets. Then definitely it will have 65,536 alphabets. Like how English has got 26 alphabets. How many alphabets in your language? Counting here. How many languages in your alphabet? What is that number? 55. See, surprise, we don't know our own language, how many alphabets are there. No? No, I am asking, like how English alphabet has value, no? Your alphabet will have also values to be there. Hindi alphabet will have also values. No? So, French alphabet, German alphabet, Japanese alphabet, every alphabet has a values. So, that is called your Unicode. That's your Unicode. So, starts with the 0, ends with the 55 fixed. 655 different language alphabets values are there. So if you take a variable of type character in Java, we can store 0 to 65535 means any language alphabet can be stored and its range will be between 0 to 65535. So 16 bits are required to represent any value between 0 to 65535. Okay, so it supports Unicode. Because of that, you can say it is 16 bits. 56 values are there. Got it? If you want to know more about Unicode, you can Google it, Unicode table. Then you can get it like what is the value for each alphabet. You can get it. Okay. I hope it is clear now why we are talking about the numbers. Because any character you store, it has a value. It has a value. The value will be in the range of 0 to 65535 in case of Java, in case of C, C++, 0 to 655. And in onside, negative value for the characters. Okay. So that's all about data types, what we have done last session, even today characters. Now let's see what are the first let me list out all the keywords. Just listing all the keywords, then we'll move the constants. This is the different constants. See what are the keywords are there. Keywords. Last session I said you is a reserved word. It's a reserved word and its meaning cannot be changed. It has a specific purpose in every language. Every language has got its own set of keywords. Okay. So it has got 53 keywords. 53 keywords. Let's list all the 53 keywords. We are not going to discuss one by one now. By the end of this course, you should be aware of all 53 keywords. Then the topic wise, you will see. Topic wise, you get to know. Let's say literals, or constants. True, null. These are the three constants. Three constant, true, false, and null. Constants and always it is also counted as a keyword. Okay, predefined constants. True, false, null. And there are two unused keywords with there also. Now it is not being used. Go to and constant. It was there, but now not being used. Still, it is left in the keywords. Go to const. Go to and const. Now see, first category is already we have gone through some keywords. Find the 8 keywords already we discussed. And one more is the called void. Void is no type associated. It's empty type. We discuss later void data types. After this, we are going to say control structure related. Control structure is if, else, switch, case, default. In if else, we have a two if else. Switch case for switch case default break. In while, we have only do while, do and while, or continue and data. So these are the keywords related to control structure. Modifiers. Okay, modifiers. Private. Protected. Static. Final. Abstract. Spectacular. Volatile. It is in the modifiers we are going to see when we start with the object-oriented programming. Okay, oops concept there. And after this, related to types, class is the keyword. By using class keyword, we can create a class. Like class, we have also interface, inner. Related to that only something like extends, implements, importing a class, import package, import and package. Okay. Then exception related and error related. Error related some keywords are there. Try, catch, throw, throws. Finally, set. And memory related. We have a new instance of this super. These are the keywords. Right? Same. 3 plus 2, 5, remaining 48. No? Here we have a 9, here 11, 9, 11, 20, 11, 31, 31, 3, 34, no? 34, 4, no? 38, no? Right? No, no. 38, 38, 6, 44, 44, 4, 48, 48 into 50, 50 plus 50. So if you remember topic wise, easily you can remember it. Easily you can remember topic wise, you remember data type, control structure, modifiers, types, error, exception related, member related, and easily you can remember all the features. Okay. We are not going to discuss now as we discussed data types now. No? After that, we are going to talk about the control structure. Then we comment on all the things. One by one, which then modifiers, types, and all this. Right? Just remember the list of keywords. Now see what is the constant is. Constant. Constant is what? Just opposite to your variable, right? Variable means is a container. It contains a value. What it contains, that is a constant. I mean, constants are the data items whose value do not change. No, constants are the data items. Constants are the data items which does not change. It's fixed throughout the program. Its value cannot be changed. Its value cannot be modified. Okay. So the first category of constant is your integral constant. Integral constant. Okay. Integral constant. Like data types, we have integral, real constant, character constant, real type, character and boolean. Four categories are there. Integral, under integral, what is it? Byte, short, int, long. Then real, float, and double, and character and boolean. Here also four categories. Integral constant. In integral, we have binary constant. Okay, octal constant, decimal constant, hexadecimal constant. Okay, hexadecimal. All are comes under integral. You take binary, octal, decimal, hexadecimal, all value can be stored into what type? Byte, short, int, long type. Okay, they can hold all these values. Any kind of value can be stored into those containers. But how do you identify it's a binary constant, which is a binary? One value is given. How do you know that it is a binary constant? Is the octal, decimal, or hexadecimal constant? So it's a binary constant. It consists of the digits 0 and 1 only. Sequence of 0 and 1. Then it must start with the 0B or 0B. Any number starts with the 0B followed by sequence of zeros and ones. Okay, like example 0B101. It's a if this is given no, then you have to say that it is a binary constant because starts with 0B. Starts with the 0B followed by sequence of 0 and 1 only. 0B 111 valid all and 0B102 is invalid. Okay, is invalid. Okay, why? Because started with the 0B, but Hence, like it contains what now 2 is not allowed. Only 0 and 1 is allowed. So it's invalid. Then octal constant. Octal. It consists of the digits 0 to 7 only. 0 to 7 it allows. It must start with the 0. Any number start with 0 followed by sequence of 0 to 7. Okay, like 0, 1, 2, 7 valid. Okay, 0, 1, 0, 0, 2 valid. But 0, 1, 2, 8 is an invalid. It's not an octal constant. It's not an, because 8 is not allowed, 0 to 7 is allowed. Decimal constant. Decimal constant, it consists of the digits 0 to 9 only. 0 to 9. It must not start with the 0. 0 is allowed, but not as a digit, because if it starts with 0, it will be treated as a octal. Any number start with 0, it will be treated as octal value, not a decimal value. Not a with the 0, 1, 2, right? 0, 1 to 7, no. It's not 127. It is not 127 is same. You might think 0, 1 to 7 is 127. No. It is in a octal form. If you convert it to decimal, you get its different value. Okay, so this is not a decimal value. It's not a decimal means as it is, right? Isn't whatever I that's the value of it. But 0, 1 to 7 is not a decimal, it is an octal value. So must not start with a 0. Like example 1, 2, 5. Okay. 2, 8, 5, 0. Valid object, valid. But if you say now 0, 1 to 7. What will happen? It's not a valid decimal constant, but it's a valid, it's not an error. Where 0, 1 to 7, it will be interpreted as octal value. It will be interpreted as an octal value internally, not as a decimal value. So it's not an error. It is not a valid decimal constant, but it is valid octal constant. But it's a 0, 1 to 8, neither it is decimal constant, nor it is an octal constant. It will be an error. If it's 0, 1 to 8, we get an error. Because it won't be treated as a decimal. Why? Because start with 0. And when it starts with 0, it won't allow 8. 0 to 7 only allowed. So neither it is a decimal constant nor it is an octal constant. So it is an error. This is an error, invalid, absolutely invalid. But this is a valid, but not a valid decimal constant. It is a valid octal constant. Okay. So whether hexadecimal constant. Hexadecimal constant. It consists of the digits 0 to 9 and 8 to 12. 8 to 12 is about 8 to F. S stands for what? For the value change. Not class is 10. A is 10, right? A is 10. 10 to 15. 10 to 15 is represented by 8 to F. What happened? Guys, I don't know the number system. A to F. Uh, A to F is the 10 to 15. 10 to 15. See why given 10 to the try to understand. Why not 10 to 15? Why 8 to F? You might think, why not 10, 11, 12, 13, 15? Why 8 to F given? See, for example, there is a number called 65. Not 65, I'll say 31. Okay, 31 is a decimal value. I want to convert this into octal. Converting decimal to octal. How to convert decimal to octal? How to convert decimal to octal? See, these are very much required things when you go for, if you are going for any certification in Java, no? You are going for any international certification, Oracle certified Java professional, right? Test, no? These are very, very required small things, which is not required. No? Data types, operators, special characters, keywords, constants. The basics are very much required. And in that book, it is clearly written in the beginning of the book. People's success in multi-threading and collection framework, like difficult topics, they secure 100 out of 100. But they fail in the basics. Because we don't give importance to basics, the basic fundamental, right? Very clearly written that. This is the for preparation, that book is there. Very clearly written that. Most of the people fail in this basics of operators, constant, data types. They'll fail. Small code fragment, they'll fail. The bigger program, they'll be able to write it. They will talk like concept wise. So these are very, very much required. How to convert decimal to binary? Decimal to binary, how to do that? Divide by 2. Decimal to octal, divide by 8. Decimal to hexadecimal, divided by 16. Remember this. At least you know that one thing binary. Decimal to binary, divide by 2. So decimal to octal, divide by 8. Decimal to hexadecimal, divide by binary to decimal. How do you do it now? Binary to decimal. Each digit multiplied with what? 2 to the power 0, 2 to the power 1, 2 to the power 2, right? Binary to decimal. Octal decimal, 8 to the power 0, 8 to the power 1, 8 to the power 2. Hexadecimal to decimal, 16 to the power 0, 16 to the power 1. Okay, just remember the formula. Say, or just let me tell you one. 5, 2, then 2 to the 4, 1. Again divide by 2, 1, 0. 1, 0, 1, 1, 0. Now 1, 0, 1. Now take 1, 0, 1. Convert it into, it is binary now, right? Convert decimal. What do you do now? 1 into 2 to the power 2, right? Calculate. Is that no? Then 0 into 2 to the power 1. 1 into 2 to the power 0. So wherever 0 is there, just ignore it. Because multiplied with 0 is 0 only. No need to calculate this. Taking 2 to the power 0, 1. Okay, even multiplying with 1 only, just calculate this value only. 2 to the power 0, 1. 2 to the power 2, 4. Is 4 is 1. 4 plus 1, 5. So 5 is converted, 101, and 10 converted, we got 5, right? Same thing apply here now. 31. What by 16, right? By 16 ones are okay. And what is the remainder now? 15, right? Yes or no? Okay. The 15, we should not take it as a 115. We take 115 problem is what? No, you will say, you will feel like this, no? Yes or no? 115 means you say individual digit 115. Then you will calculate how? You will calculate the 1 into 16 to the power 2. And this 1 into 16 to the power 1, 5 into 16 to the power 0. Then it will not be 31, it will not be. So whenever the values single digit comes 0 to 9, you take it. Whenever the remainder comes 10, 11, 12, 13, 14, 15, maximum 15 only, no? Dividing by 16, maximum remainder will be 15 only, right? So between 10 to 15, they have taken A to F. A to, so F stands for what now? Sorry, 15 stands for F. So it will be what? 1 F. 1 F1. Small f or capital F, you can take 1 F. Now convert it the 1 into 16 to the power 1, right? 1 into 16 to the power 1. Then F and F, you take 15. 15 into 16 to the power 0. So 16 to the power 0 is 1. 1 into 15 is now 15. Plus 16 to the power 1 is 16 into 1, 16. So 16 plus 5 is what now? 31. Right? That's why taken A to F. A to, whenever the two digits are remainder, 10, 11, 15, no? You need to take it as A to F. And while calculating, you have to use the value as a 10 to 15, you have to use it. Okay? So, that's what I'm saying. A to F, small a to F or capital A to F, you can take it. And it must start with the 0x or 0x. Any number starts with the 0x. 0x followed by 0 to 9 A to F. That is the hexadecimal value. That is 0x valid. It's valid. 0x is valid. Why A to F is valid? It will be like how calculated value? E into 16 to the power 0 plus the C into 16 to the power 1, A into 16 to the power 2, F is nothing. And F is 15. Then apply the values. It is 15, it is a 10, it is a 12, it is a 14. Apply. Then you get the value, that is the decimal value. That is the decimal value. This is true. 0x is also value. But if I say now 0x is invalid. R is not allowed. R is not allowed. A to F and 0 to 9 is allowed. Okay. So in this way you can identify what is the different type of constant. Binary 0B. 0B. Binary is 2 digits 0 and 1. After 8 digits 0 to 7, 0 to start with 0. Start with 0. Decimal, you should not start with 0. Remaining 0 to 9 all you can take. Normal numbers you are writing. And hexadecimal 0 to 9 plus A to F. Okay, and must start with 0x. 0. We don't just, this is for recognizing. It is not a value. Just to recognize that it is a hexadecimal. But actual value is what? This is the actual value. Okay, in this we can identify which is what kind of constant. Clear? Suppose I take variable binary value. Variable name is contained as what now? Binary value equal to 0x 1 to f. Valid or invalid? Invalid? Why? Valid or invalid? Guys, what about yours? Valid? See, you get to know your answer. Yes, yourself will get to know. Valid or invalid. This line is valid or invalid. Int x equal to 0x multiplier. Huh? Valid, right? When this is valid, then why it is invalid? It's just the name of the container only. Name everything only, right? See, look at the container type. This container is what type? If the container is of type integral, not only integral, then byte the short, int, long. If this container is the container, if the left side container is of type integral, right side we can have any value, either octal value or binary value, hexadecimal or decimal, any constant times. Because the container is integral, constants are also integral. But it is suggested to give a proper name. Getting my point? No? You should not keep, this is not an error, but not suggested. Why? Because in future, if you use this as a binary value, but it contains what now? Hexadecimal value. Container name is the binary value. Okay, but the content is what here? Hexadecimal value. See something, in a glass jar, you are labeling as a sugar, but you are keeping salt in that. What will happen? Nothing wrong. But wrong. When you keep wrong, it's the runtime. When you use it, it's the wrong time, right? It means wrongly labeling that glass jar, right? You should not keep like that, no? So like that, the content is hexadecimal, and we should not label the container as a binary. We should label it as a what? Hexadecimal. Understood, no? So the container name can be anything, not a problem, but it should be an appropriate name. It appropriate name. See, when I'm saying like this, you're saying is valid, but you are telling this invalid. It means what? The naming convention only makes troubling us cycle. When we're writing proper name only troubling us. When we're writing X, Y, Z, ABC, we understand properly. But this is not suggested to write also. Why? This is not suggested because X is not a valid, it's not a meaningful name. It's not a meaningful name. And here, this is not given a proper name, not given also. Content is not proper type. So if you are keeping a binary value, give binary value. If you are keeping hexadecimal value, give a X value. Like that, you keep it. Okay. So next class, I'll show you one program of this. There's 4 constants. We take 4 variables, 4 different constants. How do we do some calculation on that? How the calculation happens internally. How we are converting all the types into decimal and getting the value result later. Okay. So next lesson, I'll tell you 2, 3 programs based on data types and constant variations. Then we'll see the operators. Okay. Thank you. Go through that. I have sent you the file, Say this one I have sent you. Remember, okay. There's a text file called java.text file. Java.text file. So you can see whatever we have discussed as of now, variables, declaration, everything is given. Just go to this. Okay. So that we get out. Then today we discuss constant. That also. So thank you.